I've been in the statistics game since 1966, really. I started well, actually started before then, but in 1966, which is a very different time to now, my first job was to try and introduce computing, as it then was, into a statistics course at the University of Adelaide. And ever since then, I've been very involved with trying to get people to use software in innovative ways to address real problems that occur largely in statistics, but in applied statistics all over the place. I think the first real change came with interactive computing, where people actually had consoles and they could actually access the computer in real time. Now, this sounds pretty normal now, but in the old days, it was a revolution. And you had systems coming up like GenStat, which was a card-based system originally and remains so. Well, it doesn't remain a card-based system, but it remains a system where the fact that it was originated with cards is still evident. But the thing is, they were specific purpose software devices that were for solving statistical problems. I think the first real interactive one, though, was GLIM, which was software meant to implement the idea of generalized linear models. And now both GenStat and GLIM were started by John Nelder and his colleagues, including Graham Wilkinson, and a lot of the work was actually done in Adelaide. So CSIRO and the University of Adelaide were on the same block. They had joint buildings, really, at the time. So I had a lot of work to do. I had a lot of interaction with CSIRO people as well as the University of Adelaide people. And I think GLIM really opened my eyes that you could do things very swiftly and very effectively. But GLIM took off very swiftly there. The idea is the freedom that you got by being able to do things immediately at the computer was very popular. I think the next real big step was the introduction of a language called S, which was the antecedent to what we now call R. This was a much more developed language than GLIM. It was a universal language that could be used in principle for almost anything to do with computing. It had a lot of inbuilt software behind it that you could string together. And the internet had started. And there was a helpline for the S people using the S language in a software device called S+, that had people asking questions and people offering answers. And for some reason, I found this very interesting, and I contributed a lot. I suppose these days you'd say I was an early influencer, which seems pretty silly nowadays, but I built up a big clientele, or not exactly a clientele, but connections with people all over the world. And I demonstrated that I could solve these problems, but really what was going on, the power of software and the power of being able to write software that implemented ideas that you had and clarified ideas that you had was becoming very important. About software is that it's halfway between an art and a craft. The thing about it, you need to be imaginative and you need to be very constructive in the way you go about it. But on the other hand, you've got to be strict in your logic and you've got to obey. It's ironclad. The rules are ironclad. So you have to work within a very, very firm framework. So I think of software development as really a tool for clarifying and ensuring the cogency of your reasoning for a problem. If you can program it, if you can implement it in code, it means, and it works efficiently, and the code is clear, then it reinforces your understanding of the topic. And I think that's why it's so important. If you're new to the area, and the whole thing's a bit surprising, really, because it's surprisingly interesting and surprisingly challenging. If you get a good idea, or if you've got a problem and you found an interesting way to solve it, and in other words, your solution, first of all, addresses the problem at hand, but is sufficiently well written and sufficiently generic that other applications easily fall into place. I think that's the kind of problem or the kind of contribution that might be useful to develop for the purposes of this award. But I don't think it should be restricted to people who are actually young necessarily, but are young to the topic. So quite often I deal with colleagues who are, well, they're always younger than me, but they may be mid-career researchers who suddenly find that the challenges of dealing with data are more interesting than they thought. And they come to it with fresh ideas fueled by what they do in their own domain area. And they give you an interesting way of looking at data yourself. And if they've got an idea that they can implement that actually has further application from their own domain area, well, I think that sort of thing is, and they've got a good way of implementing it. So it might be something in machine learning, or it might be a new way of visualization, a new graphics idea, or a new idea for how to, whatever. If it's new and if it's got, first of all, it solves a real problem now, but it's done in a generic way that allows it to be developed so that it extends to other problems that are related. I think that's the sort of thing that the committee running the program should be looking for. And I think if they can find many of those and they can actually show them, it will have achieved its purpose. I think the word sort of explains itself. It's people that that are either doing data science degrees, or they've done data science degrees, or they've done statistics degrees with a good data analysis and visualization, even with a strong mathematical background. But I think the people that would be most interesting to me are people that are actually newcomers to data science or data analysis or visualization, that come with a problem that's new to the data science community, and bring with it a new way of solving that problem. And this new insight actually leads to further developments in data science itself. Not necessarily, they have to be big things, they just have to be innovative, and they've got to be well implemented. But I think another thing that we haven't emphasized up to now is that it's got to be open source. It's got to be fueled by a kind of generosity, that you want this idea to be shared with the community and with others like you. I think that's very important. That you can't actually build a silo in data science. You've got to work with other people. You've got to maintain your connections. So it's difficult to get an appreciation. It's always been difficult to get an appreciation that you have a special contribution to offer to your application, your domain communities. So it's hard to establish the fact that you are professional. And I think an award that, like this one, that can reinforce the idea that this is both a collaborative science, but it also has unique features that are important, is something useful. It's very hard to put your finger on it, but we need more prominence in the scientific and even in the commercial community. A prominence in the commercial community that's almost pretty well established now, but in the scientific community, it's still quite common for domain experts to have a statistician or someone that acts as a statistician or a data scientist, or even a database person to do a bit of stats on the side. And that's the sort of thing that we've got to try and alert people to the fact that this is that they're missing out. That collaboration with professionals in other areas in the data science area is something that could benefit both sides. And if you can plant this seed in young people as they come through, that their data science as well as being collaborative, has an independent structure and independence, as well as the necessity for collaboration. I think that's important. Well, first of all, about the award, I would say that it was not my initiative, and I won't be involved with devising rules or implementing assessments or awarding prizes. I'm just happy to have people ask me to support it, and I'm happy to do so because I think it's very important. I think it's any recognition you can give to young people or to people new to the topic, not necessarily all that young, new to the topic, that raises the profile of this rather awkward topic, this rather awkward game that we're in, that's inevitably collaborative. I mean, it's not pure mathematics. It's not applied mathematics. It's essentially a collaborative effort that has to work with other people. You have to work with other people. You've got to see, it's the domain expert and the data analysis expert each have a contribution to make. And establishing your own authenticity and your own value as a discipline, while at the same time having to work with other people, is a challenge, but it's a useful thing to do.